Welcome to David Alexander Maths Tuition. This is chapter 7F, proving trigonometric identities. Okay, so we want to show that cos squared x is 1 plus cos 2x all over 2, and this is one that is definitely worth remembering. I would normally remember it as cos squared x is a half plus a half cos 2x. So it all comes from knowing that the cos of 2x is cos squared x take away sine squared x, and another way we can write that is 2 cos squared x take away 1. So all I need to do is add 1 to both sides and then divide by 2, and there is my proof. So cos of 2x plus 1 all over 2 is cos squared x. Now for the next one, we know that cos of 2x is cos squared minus sine squared. So another way we can write the cos of 2x is 1 minus 2 sine squared x. So I'm going to subtract 1 from both sides. Now I'm going to just turn this into 1 take cos 2x equals 2 sine squared x. So I've just flipped the signs there, or multiplied through by -1. And now dividing through by 2, 1 minus cos 2x all over 2 is sine squared x. There we go. As I say, worth remembering these. I'm sure I've mentioned it in previous videos. Learning that cos squared x is a half plus a half cos 2x, and sine squared x is a half minus a half cos 2x can really get you out of trouble in some of these nasty questions, and also when you're doing some of the integration later on as well. Okay, so what we can do with this one, we know that the sine of 2x, there's only one way we can write the sine of 2x, and that's 2 sine x cos x. And we want to show that this is the same as tan x, which is sine x over a cos x. So this cos x is going to stay, so the sine x we're going to have to get rid of. So the only way I can get rid of a sine x on the bottom is if I've got a sine x on the top as well. Now we know that the cos of 2x is cos squared x take away sine squared x, and that can be written as 1 minus 2 sine squared x. So I'm going to go with this one because I want some sines on the top, and 1 minus 2 sine squared x, that is the same as 1 minus 1, which is 0, plus 2 sine squared x. So that's 2 sine squared x over 2 sine x cos x. Well, the 2's will cancel. We've got a sine on the bottom and a sine on the top, so that becomes sine x over cos x, which is tan x. So there we have it. The left hand side is now the same as the right hand side. Okay, so for this next one is quite similar. Sine of 2x is 2 sine x cos x, and as I'm aiming for a tan x, which we know is a sine over cos, I'm going to have to get rid of this cos. So I'm going to turn I want a cos on the bottom, so it cancels with the cos on the top. Now the cos of 2x is cos squared minus sine squared, but another way that we can write the cos of 2x is 2 cos squared x take away 1. So we have 1 plus 2 cos squared x take away 1. Well, 1 take away 1 is nothing. These 2's will cancel out, and I've got a cos on the top and a cos on the bottom, giving me sine over cos, which is tan x as required. Okay, here are 2 more. So cos x squared, we need to remember, is 1 over sine squared x. Now sine squared x, that is, I think it was the very first example, sine squared x can be written as a half take away 1 half cos 2x. So what we have here is 1 over 1 half minus 1 half cos 2x. Well, if I double the top and double the bottom, then I get my 2 over 1 minus cos 2x. Okay, this bottom one looks quite nasty. Now, when I see a sec squared minus 1, that makes me think of one of the trig identities. So we know that sine squared x plus cos squared x equals 1. Now, if I divide through by sine squared, if I divide through by cos squared rather, that will give me tan squared x plus 1 equals sec squared x. So sec squared x is tan squared x plus 1. So what we have here is tan squared x plus 1 take away 1 over sec squared x. So that is tan squared x over sec squared x. Now tan squared, that is sine squared x over cos squared x. And we've got sec squared as a denominator, which is cos squared as a numerator. And these coses will cancel out, leaving us with the sine squared x. Okay, so we need to show that the tan of theta plus cot theta is the same as 2 cosec 2 theta. So we need to consider perhaps that tan of theta is sine theta over cos theta, and that cot theta, it is 1 over tan theta, but easier if you see it as cos theta over sine theta. So let's add these fractions together. So that's going to be sine squared theta plus cos squared theta over cos theta sine theta, or sine theta cos theta. So that is 1 over sine theta cos theta. Now I know that the sine of 2 theta is 2 sine theta cos theta. So therefore 1 sine theta cos theta is a half sine 2 theta. Now if I've got sine 2 theta as a denominator, I can write that as, I can bring that up and turn it into cosec 2 theta. So that is cosec 2 theta over a half, and anything divided by a half is the same as multiplying by 2, so that is 2 cosec 2 theta, and we've proved it. Hence find the value of tan 35 plus cot 35. So replace theta with 35, so what we have here is 2 cosec 70, and that is the same as 2 over sine 70. So let's just grab the calculator. 2 divided by the sine of 70, and we get 2.13 to 2 decimal places. Okay, so for the first part here, we need to show that the sine theta is 3 sine theta cos squared theta minus sine cubed theta. So I'm going to say that the sine of 3 theta, that can be written as the sine of 2 theta plus theta. So if I expand that, that's going to be sine 2 theta cos theta plus cos 2 theta sine theta. Now the sine of 2 theta, that is 2 sine theta cos theta times the other cos theta. Now the cos of 2 theta, I can write that as cos squared minus sine squared. In fact, let me just do that. So that's cos squared theta minus sine squared theta multiplied by sine theta. So what we have is 2 sine theta cos squared theta plus cos squared theta sine theta, take away sine cubed theta. Okay, so we're getting somewhere. I can subtract the this cos squared theta sine theta, that's the same as the sine theta cos squared theta, so that is 3 sine theta cos squared theta minus sine cubed theta. There we go. So we have proven that first part. So I'm just going to delete the ink to clear things up a little bit. Okay, so for this similar, I'm going to say the cos of 3 theta, that is cos of 2 theta plus theta. So that is going to be cos 2 theta cos theta, subtract sine 2 theta sine theta. Now the cos of 2 theta, that is cos squared theta take sine squared theta, multiplied by the cos theta there. And the sine of 2 theta, well, that is 2 sine theta cos theta. And 2 sine theta cos theta times this sine theta is 2 sine squared theta cos theta. Let's expand the left hand side there. So that's going to be cos cubed theta minus cos, oops, that's an S, cos theta sine squared theta minus 2 sine squared theta cos theta. I should have kept it as sine squared cos theta there. These two are like terms. Doesn't matter that the cos and the sine are the wrong way around. So that's going to be cos cubed theta minus 1 minus 2 minus 3 sine squared theta cos theta, which is what is required there. Again, I'm just going to delete everything now. Okay, so for this last part, we need to show the tan of 3 theta. Well, the tan of 3 theta, that's going to be the sine of 3 theta over the cos of 3 theta. In other words, it's going to be 3 sine theta cos squared theta take sine cubed theta. I'm going to leave a bit of a gap here, divided by cos cubed theta, take away 3 sine squared theta cos theta. So I need to turn this into a 3 tan theta, and I need to turn this sine cubed into a tan cubed. Well, how about, I know that to get from a sine cubed to a tan cubed, I would need to divide by cos cubed. So let's divide everything by a cos cubed theta. Okay, so let's look at this first part. 3 sine theta cos squared over cos cubed. So I've got 2 coses on the top and 3 on the bottom, so I can cancel out 2 of them, leaving me with a cos theta. So I've got 3 sine theta over cos theta, well, that is 3 tan theta. Sine cubed over cos cubed is tan cubed theta. And on the bottom, cos cubed over cos cubed, well, that's just 1. And on the bottom, this cos theta on the top can cancel with one of the 3 coses on the bottom. So I've now got cos squared on the bottom. Sine squared over cos squared is tan squared. So that's 1, take away 3, tan squared theta. There we go. And we have proven it. And for the final part, given that theta is acute and the cos of theta is 1 over 4. Okay, so if the cos of theta is 1 over 4, then let's do a right angled triangle. Here's theta. This is 1. This is 4. So we know the adjacent and the hypotenuse, so therefore the opposite is going to be the square root of 4 squared to take away 1 squared, which is root 15. So therefore the tan of theta is root 15 over 1, or root 15. But is it positive or is it negative? Theta is acute, so C, think of our cast diagram, CAST. If it's acute, it's in this quadrant here, so all sine, cos and tan are positive, so it is positive root 15. Okay, now we know the tan of 3 theta is this stuff here. So it's 3 tan theta, well, tan theta is root 15, so that's going to be 3 root 15. Take away tan cubed theta, root 15 times root 15 times root 15, so that's going to be 15 root 15s, over 1 minus 3 times tan squared theta. Well, if tan theta is 15, root 15, then tan squared theta is 15. So it's going to be 1 minus 3 times 15. So 1, take away 45. So that is going to be minus 12 root 15 over minus 44. So 12 root 15 over 44. And 12 over 44, that can simplify to 3 root 15 all over 11. So there we go. That is the value of the tan of 3 theta. And we're done.